Hey guys, so today we'll talk about regression metrics and different types of regression metrics and where to use them and some of the properties. So let's get into the agenda. So I made the agenda and the presentation so that it's grouped together of how they treat outliers. The reason being is because there are many regression metrics out there and it can get confusing. So I hope this can mitigate this confusion. So we'll cover overall 6 of those metrics. So let's start with the first batch, which is the metrics which are sensitive to outliers. So those are the metrics that say that, hey, if they look at very big outliers in your data set, then it will penalize those outliers and it will say, hey, this is bad. We want this to be an error. So we have the mean squared error, which looks like this. And then we have the root mean square error, which looks like this. So that is the square root of the above. So this is very useful because it's the same unit as the target variable, so it's quite nice. On top of that, overall the mean square error is quite nice as well because it's basically you can differentiate it and you can do a lot of mathematical things with that, which we won't get into now. The next group is the metrics that are quite robust with outliers, so they don't over penalize the outliers, such as this group here. So we have the mean absolute error and then the mean absolute percentage error right here. And in the mean absolute error, again, it's the same unit as the target variable, so it's nice to understand. And one thing to note about the mean absolute error is that you don't want to have a division by 0, so just keep that in mind if you choose to use it. And the last batch is the overall fit. So this is a different type of metrics where it says that if the value is very close to 1, it's a good metric, and if the value is very close to 0, it's a bad metric. So if we have r squared right here, which looks like this. And then we also have adjusted r squared, which takes the predictors into account. So the more predictors you have, or the less predictors, the adjusted r squared value keeps that in account. This is very useful because when you do a lot of machine learning experimentation, you may want to try different predictors, different features, and having r squared keeps that in mind, whereas having using the adjusted r squared keeps that in mind, whereas r squared doesn't. And so yeah, this is overall the only 6 metrics I wanted to talk about in this presentation, and I hope you enjoyed it. Thank you guys.